In the last class, I think we did up to question number 31, so we can continue from there. 31. So I've been telling you sigma f is equal to ma, right? Again and again we keep using that. It's the most important formula, I would say. So 31. Yeah. So very often you will get these kind of connected bodies, like connected with a string, connected with a rope, lift problems, and sometimes blocks in contact. So the concepts are somewhat similar. So we can try this tension. I think we did some tension based problem here. Inclined plane problem, tension based, string based problems, lift based problems, right? So these are all some constant regularly asked questions. If you're not muted yourself, please mute. If you have doubts, you can always ask. Okay, unmute yourself and you can talk. So 32. So there are three masses. One is hanging, right? The other two are on the table. So rough horizontal table, which means there is some friction. So that is your mu. Friction is the mu. So let's see how we can do this problem. So I would say mass M1 hangs freely and M2 and M3 are on the horizontal table. Coefficient of friction, pulley is frictionless, negligible mass. Downward acceleration is of mass M1s. So they're asking you to find the downward acceleration. M1, M2, M3 are same, so all the M's are same. So that means immediately I can say that there is some tension in the string. So that means tension is acting upwards, mg is acting downwards, right? And then they're asking you to find the acceleration downwards, which means this is A. So these two are forces, this is acceleration. So I have to show it separately. So somebody is pulling this way these masses, so that means the tension here should be equal to the tension here. Why? Because we told since it is connected with the same rope or same string, the tension has to be same, it cannot be different. With respect to this block, the tension is pulling this way. With respect to this block, the tension is pulling this way. This is where many of you will have some trouble understanding, right? I think I already explained you. So why is this not falling down? Because somebody is holding up. Why is this coming this way? Because somebody is pulling it this way, and that is your tension here. There is going to be some friction here, some friction here. So F friction is equal to mu into N. You know that N is going to be normal reaction, so this is mg. That means normal reaction is going to be this way. So mu into mg. You can see that there are two F frictions, right? So it's going to be the same here. I'm not going to write again here because I don't have enough space here. So I think I can directly do tension T minus, this is acting this way, right? So that means sigma F is equal to MA. So T minus 2 times mu mg is equal to, if this is going down with an acceleration A, this should also be moving with an acceleration A. So that means it will be 2 times the mass 2m into A. So in this particular case I am taking this as tension this way is positive and this side it is negative. Okay, usually we will take right side as positive and left side as negative. But here nothing wrong if you follow a different convention, right? As long as you follow the same convention for the entire problem. Similarly, if you write it for the vertical thing, sigma F is equal to MA. So T minus mg is equal to MA. Since it is going downwards, I told you we have to put a minus. Okay, so here this way I have taken it as positive, so this is positive. This way it is negative, and since acceleration is on also this way, I am taking it as positive here. Since there are two masses, this is 2m. Since there are two frictions here and here, then it will be mu mg, so that means it is 2 times mu mg. That's all. Simplify this, you will get the answer. So I have to get rid of t so that I can find the a. So if you want, you can take it as equation 1, equation 2. Eliminate t, you will get the answer. So that means t minus 2 mu mg is equal to 2ma. I told you I want to get rid of t, so that means elimination method, plus minus. This will be 2 mu minus mg, so mg is common. So 2 mu minus 1, ma is common, so minus of minus it will be addition, so that means it will be minus 3 ma. Can be cancelled. So I want a, so a is equal to minus g, so 3 comes in the bottom, g 2 mu minus 1 divided by 3. So if you take the minus inside, it will be minus 1 minus 2 mu, 1 minus 2 mu. So that's my answer. Anybody having any doubts? Very simple, very easy. Please, if you have anything not clear means, please raise your doubts immediately. It's all very easy problems. You should not have any doubts at all, right? If you have, please raise your doubts immediately. Don't keep it in your mind. Once you write this equation, after that is simple mathematics, right? Solving two equations, 10th standard.
Sir,
Yeah.
sir, M1 is equal to M2 is equal to M3. If we consider M1 is equal to 5 kg, then M2 also 5 kg and M3 also 5 kg. So totally there's 10 kg. How come the mass M1 can able to pull the two 5 kg masses, downward acceleration?
Yeah, good question. But I think the answer is something to do with the gravity. You see, this is, it is acted upon by m into g, right? Whereas this one, the mg is actually acting on the table. It is not. So it's only because of the friction it is kind of holding it here. Suppose if there was no friction, what will happen is this entire thing will be pulled this way. So
Yes,
your doubt is valid, but you have to understand that here the table is holding the masses.
Yes, two more.
So only if somebody is pulling it in this rope, it will start moving. Otherwise, it will not move. So,
Okay.
so that means who is pulling this? This one, this mass. So M into G is what is pulling it. So in other words,
Yes, sir.
I'm saying that it depends upon the friction. If you have more friction, this cannot pull it at all. If you don't have friction, then a very small mass can actually pull this. Okay,
Yes, sir.
because mg is acting downwards, but somebody is pulling in the side. Or if you are not convinced, you can imagine like you have like a huge block. Let's say it's like 50 kg or 100 kg. And how come we are able to push it? Because we are giving the force this way, even though the gravity is acting this way. We are giving a force this way. So that means we are doing a horizontal push or pull. So that means, in other words, this is mg, this is normal reaction n. So your question is, sir, how can we push such a big mass? And the answer is, it doesn't matter whether it is big or small. What matters is what is holding it back. If you have a smooth surface, it's very easy for me to push it. I can even push a 1000 kg block on an oily surface. Are you following?
Now I can understand, sir.
Yeah, so that
Yes.
means the friction is what is acting in the horizontal direction, F friction. So F friction is equal to mu into N. I agree that bigger the mass, the normal reaction will be higher. Do you agree?
Yes, sir.
Bigger the normal reaction, the friction will also be higher. Do you agree?
Yes. Yes, sir.
However, it is proportional to this mu. So that means instead of 0.1, if it was say like 0.01, then this effect is going to be very, very less. So that means I have to give only 10 times less force compared to zero point 0.1. In 0.01, I will be giving less force. Instead of 10 Newton, I will be giving only 1 Newton. Okay.
Yes, sir. Thank you.
So that means your thinking is valid, but you have to think that um, who is holding this? So it's a horizontal friction which is holding it. Right? So if I am giving more than this friction, then obviously this will start moving down. Okay, very good. So if you have this kind of thinking, it is very good actually. You will learn more, and as we do, as you get some answers, you can double check whether whether it is making sense or not. For example, if they said no friction, right? What will happen? No friction means mu is equal to 0. Do you agree?
Yes, sir.
That means this term will go away, which means g by 3. So that means what that means is even without if you don't have any friction at all, then the acceleration will be g by 3. If you had friction, then the g by 3 value will actually reduce. It will be moving down very slowly, right? Which means this value will increase, which means this value will decrease. So that means the g by 3 value will actually decrease. So this is a very, very important type of problem, right? You can call this as tension problems or string problems. I think we have been doing a lot of questions based on this, especially this one, this one. This is not string, but the concepts are same. And then I think we did some monkey problems, inclined plane problems. I remember doing some monkey problems very often. Tension, yeah, you see. Go back and check all these things are like basic methods. Yeah, remember the monkey problem? We did this. So again and again and again, we'll be using the same concept. Sigma f is equal to ma. So if you know that, you can do these problems. And I also told you where to look for the handbook reference material. So, so every class I've been showing you this. So Newton's laws of motion. So very important chapter because only if you know how to deal with if you see the arrangement of chapters, the first few chapters we will be dealing with velocity and acceleration. Then we will be dealing with forces. And then we will be dealing with work power energy. So that means these are all the building blocks of the remaining chapters. If you know acceleration, velocity, force, work power energy, all the remaining chapters will make sense. Otherwise, it will not make any sense at all. So you see static friction, kinetic friction, inclined plane, right? So inclined plane problems, and then contact forces, right? When some block is acting, there will be some contact forces on both sides. I given some examples, so you have to study all these things. Okay, it cannot be made easier than this. Okay, so I've seen many books. I've tried to make it as easy as possible for you. So take some effort, take some 1 or 2 hours. You have to sit and study this chapter. Very very important. And you have to study this connected bodies, right? Vertical, horizontal, monkey or person climbing up, right? Apparent weight in a lift, very very important, right? Action reaction pairs, pseudo force is coming later, right? Any of these 2 or 3 pages, I would say most important pages in your physics. So I would say you have to work out all these 3 pages properly, 3 or 4 pages. Okay. 3 blocks A, B, and C of masses 4, 2, and 1 are in contact on a frictionless surface. If a force 14 Newton is applied on the 4 kg block, then the contact force between A and B. You can do this in a couple of methods. So let's try some direct method first. So A, B, C, 4 kg. We don't have space here, so I'm going to write it here. 4 kg, 2 kg, 1 kg. I said no friction on the table, so I don't have to worry about the friction. 14 Newton is acting this way. So they're asking to find the contact force between A and B. So that means this will go and push this one. But then according to Newton's third law, there will be a contact force like this. So that means this you can call it as A to B. This you can call it as B to A. Okay, so that means you should know that it's equal and opposite. So this is what they are asking. So contact force between A and B is what is asked. But you know that this will go and push this way. So that means you should call this as FB to C. This you can call this as FC to B. Okay. And let's say this entire system of block is getting accelerated with an acceleration A. So that means we have studied something called free body diagram. Free body diagram. So that means each one you have to draw it separately. That is called FBD, free body diagram. So free body diagram of C. So just to save the time, I think, okay, for your benefit, I will say I can draw it. So the only force which is acting here is FBC. Sir, what about this FCB? Well, FCB is acting on B, not on C. So that means I should take only this one. There is no other force. If you take it for free body diagram for B, then suppose if there was some friction here, I would have added friction also here. If this is moving this way, I would have added friction here. So somebody is pushing this way and we called it as from A to B. Somebody is pushing this way, we called it as FCB. That's all, no other force acting on B. Free body diagram for A. So this external force is acting, so 14 Newton, first thing to write. And who else is acting? FB to A. So that means on this side, FB to A. No friction here. If the friction was given, I would have added F friction is equal to mu into N, so mu into mg. So N is equal to mg, I would have added it over here. That's all. If you know how to arrive at this, this drawing and this drawing, right? Again, in the exam, I'm sure you will not have time to do all these things. So, but right now when you are doing it, I would recommend you to do it properly. This is a proper method so that you don't make any mistakes. Once you do some, 5 or 10 problems in this method, you will become an expert. You can quickly do it, without doing the free body diagram. Until you become an expert, you have to follow the methods properly. So I know only one formula, sigma f is equal to ma. So there is only one force FBC is equal to mass is 1 kg, acceleration is a. This will be FAB minus FCB. I forgot to put the acceleration here. So this is, all of them are accelerating with an acceleration a. So in free body diagram, you have to show the forces and the effect. Forces are the cause, acceleration is the effect, cause and effect. Mass into acceleration. Mass is 2 kg into A. 14 minus FBA is equal to mass into acceleration, 4 kg into A. So A is same. So I can substitute FBC is equal to FCB. So that means I can put A over here. You may be thinking, sir, is it not minus A? Well, we already taken care of the direction. So you don't have to put, you should not put minus A here because we already taken this as, so the magnitude, the direction is already taken care. Only the magnitude you have to put, and the magnitude is A. Okay, these are all the common mistakes you folks will do. So FAB minus A is equal to 2A. FAB is equal to 3a. If I put 3a over here, again the same concept, magnitude, the direction is already taken care of. So you should not again put a minus here. So 3a is a magnitude. So that means 14 minus 3a is equal to 4a. So that means so a is equal to 2 meter per second square. So that means a is equal to, oh, they didn't ask a, they asked you to find the force. So that means a is equal to 2, and FAB or FBA is 3 times 2. So 3 times 2 will be 6. So 6 is your answer. You see, I was about to choose this one. I realized that luckily they are given Newton. So I realized that this is only acceleration, right? So that means 3 into 2 will give me 6. Any doubts? Very, very important type. I'm sure many times they will ask you this kind of questions. Easy, right? Nothing very difficult if you follow the method. I'm not sure, maybe we can try it. I think a quicker way could be, right? Sometimes the quick method may not work, right? So the quick method is, I can imagine that this entire block is one single block. That means 4 plus 2 is 6, 6 plus 1 is 7. So that means F is equal to MA, sigma F is equal to MA. So force is 14 Newton and M is 7. So A is equal to 2. So you see, I got A is equal to 2 very quickly compared to this. But this is the actual proper method, right? There are some situations you will not be able to get this right. And even if I found this A, what is the use? Again, you have to, do this FAB, FCB, all these things. Only if you do this, you'll be able to get this. But maybe you can use this for double checking. Okay. So very important method. If they want to make it a little more complicated, they will give you friction here. That's all. Otherwise, the method is exactly the same. So we just have to add the friction also here, mu into n. Any doubts? Can I move on? No doubts?
No, sir.
Okay, very good. One end of the string of length L is connected to a particle of mass m. The other end is connected to a small peg on a horizontal table. Okay, the English might be slightly confusing. So peg means it's something like a stand, like a vertical stand. So that means string of length L is connected to a particle of mass m and the other end is connected to a small peg. So that means, okay, maybe it is connected over here. The particle moves in a circle with the speed of y dash. I think it's a printing error. Speed means we don't give y. I think we will give v. Okay, I would say let's take this as v velocity. So let's say it's moving around with the velocity v, circling. The net force on the particle directed towards the center is. You know that whenever there is some circular motion, right, there is something called centripetal force. So that means the tension is acting towards the center, and that tension is what is providing the centripetal force. So centripetal force required. I don't write it as centripetal force. I write it as centripetal force required. Okay. So mv squared by r. So to achieve this speed and achieve this radius of circle, you have to give so much of force. Only if you give so much of force, it will be able to go around the circle. So that means somebody has to give the force. When a car is taking a turn, the tires and the road, the friction between the tires and the road is what is giving the centripetal force. Everyone following? This is required, right? So this is a theoretical value required. When the electron is going around the nucleus, who is providing the centripetal force? Anybody? No answers. There is something called positive charge in the nucleus, and then there is something called negative charge in the electron. So there is some electrostatic force of attraction, and that is what is providing the centripetal force to go around the circle. The case of Earth, and then you have Moon, right? So this is Earth and Moon. Who is providing centripetal force? Hmm? Who is providing the centripetal force? No answers. So it's a gravitational pull, right? So the gravitational force between the Earth and the Moon is what is providing the centripetal force. So that means in the case of a string, it is a tension. So somebody is pulling it towards the center, and that is what is making it to go around the circle. So that means tension is equal to mv squared by L. So the net force acting on the particle is, again I can use the same concept, sigma F is equal to ma. So sigma F is tension is acting this way. There is no other force to my knowledge in this way, right? So that means T here, and then m into acceleration is v squared by r. Why v squared by r? That is your centripetal acceleration. So you see, this is the most important formula, sigma F is equal to ma. So far we have been using it in the linear world. Now we are using it in the circle. So circle means it will be the acceleration is not linear, it is centripetal acceleration v squared by L. Coming back to the question, the net force is only T. Okay. So net force acting on this thing, right? So this is a net force. So they are asking only this one. So it is actually T. Some of you might make the mistake of choosing this because it looks tempting to choose T minus mv squared by L. But they actually ask you what is the net force, right? So net force means this is actual force. This is the effect. Remember I told you net force is cos. This is mass into acceleration is your effect. Acceleration is your effect. So cause and effect. If it was vertical motion, right, which is coming later, if it was vertical motion, it would be tension here, then mg would be acting downwards. Then I would have taken this as sigma f is equal to ma. So T minus mg is equal to mv squared by RL. That is for the vertical circular motion. And suppose if the mass was here, then the tension will be acting this way. Mg is also acting downwards always. So in this case, I will write this as sigma f is equal to ma. So T plus mg. So that means it's not T minus mg. T plus mg is equal to mv squared by r. I think I talked about this somewhere else, I don't remember. But the concept is towards the center is positive, away from the center is negative. You see mg is negative. Towards the center is tension is positive, towards the center is mg positive. So that means here it is positive. So in the case of circular motion, towards the center is positive. If you have not taken it down, take it down properly. Okay. Towards the center means we will take it as positive force. Away from the center means we will take it as negative force. Okay. The linear world towards this way is positive, this way is negative, right? And upwards means positive, downwards means negative. So this is, I'm sure you will not have any confusion. But circular motion means towards the center positive, away from the center negative. Very, very important. I can show you where you can refer for that in the handbook. This is in the laws of motion chapter. So you have to go to the previous chapter, which is circular motion. Yeah, I think we talked about this circular motion sometime back. I remember talking about death well, rotor ride, right? Centripetal force demanded or required, right? Ball tied to a string, electron going around the nucleus, moon going around the earth, airplane taking a turn, cyclist taking a turn. These things are coming in your 12th standard, so don't worry about it. Okay, this is coming in magnetism chapter. Conical pendulum, you should know, right? This is what I talked about. Car taking a turn in circular road, car taking a turn in the banked road. Okay, so a lot of important things for you to study. So I would say this circular motion and laws of motion are very closely connected chapter. Okay, so you will get a lot of questions connecting these things. Okay, so a lot of theory concepts here. Okay. Okay, this is a very, very important type of problem. Very often students find this difficult, so please pay attention. We get some water. Let's go through this. Okay. Two blocks A and B of masses 3m and 1m respectively are connected by a massless and inextensible string. The whole system is suspended by a massless spring as shown in the figure. The magnitudes of acceleration of A and B immediately after the string is cut or respectively. So if I go and cut this, what will happen? That's the question. The moment I cut this string, what do you think will happen to B? There is a string here, somebody is pulling it upwards. This is acting downwards, mg. So the tension is acting upwards. That is what is holding this without falling down, right? This tension. And somebody is pulling this downwards, and that is your tension on A here. So that means this tension and this tension are same. And there must be some spring force acting from the spring which is holding it, right? Otherwise it will fall down. And one more force which is acting is 3mg, because 3mg is acting downwards. So that means if I think about A alone, tension is pulling downwards, 3mg is pulling downwards, F spring is acting upwards. So sigma F is equal to ma, most important formula in mechanics. So F spring is acting upwards, so it is positive, minus tension acting downwards, minus 3mg acting downwards. You see right now it is not moving, right? So it's kind of in equilibrium. So when it is in equilibrium, it means acceleration is 0, not moving. But now, in this, if I come for this is for A, so for B, tension is acting upwards, mg is acting downwards, so T minus mg is equal to 0. Again, I'm telling you, if you're wondering why did I put 0, because acceleration is 0, it's not moving, right? It's kind of standstill before cutting the string. So that means T is equal to mg.
So why we are putting minus t for the A?
Why we are putting?
So minus t for A.
Maybe my drawing is not good here. I have to redraw this a little more accurately. So your spring is acting this way. The weight in the bottom, it is actually pulling it downwards. Do you agree?
Yes, sir. Yes, sir.
So that means the weight of this block is this one, 3mg, and then the tension is actually pulling it downwards. So that's what I told you. This is very confusing for all of you. So you have to understand that this block is not falling down because the tension is actually pulling it upwards. Who is pulling it downwards? This guy is actually pulling this guy downwards, which means the tension here is actually acting downwards. Do you agree?
Yes, sir.
So yeah, the diagram is not good here. I don't have enough space. So this might be better.
Now it is out.
Hmm?
Now the diagram is clear, sir. Now I
Yeah.
understand.
Yeah. So if I substitute mg over here, I will get minus 4mg and F spring will become 4mg. So that means let me write it in a different color.
Sir,
Yeah.
sir, since two masses are hanging in the spring of masses 3m and m, so we can directly say 4 mg motion.
Yeah, you can say that, but as I said, for double checking, you can do that. Sometimes um, it might be slightly confusing. I'll tell you why it is required. Okay, as we do the problem, you'll understand. Yeah, what you said is correct. 3 plus 1, 4, so 4 mg for the F spring. That's correct. Yeah, but still, I would recommend you to follow this method. Okay. Why? Because when you cut the string, what will happen to the tension? There is no tension at all. Do you agree? When you cut the string will go
Yes, sir,
like
no
this.
tension.
So that means the tension will become 0. So now only if you have these equations, I can substitute 0 here. Do you understand?
Yes, sir.
So that means if I put tension is equal to 0 here, then the acceleration will be, so now if I use for B, again I have to use sigma F is equal to MA. But remember, when you cut the string, it is not in equilibrium anymore, so you have to put MA. So that means T minus mg is equal to MA. So T becomes 0, cancels. So cancels, so acceleration is nothing but minus g because it is acting downwards. So that means the B is going to fall down with the acceleration of g, which is free fall. For A similarly, sigma F is equal to MA, F spring minus T minus 3mg is equal to MA. F spring we found it as 4mg before cutting the spring. So that means when I cut the string, it will become 0 here. But I think I made a mistake here. Is it MA or 3MA? Anybody? What is the mass for A? 3M or M?
Sir, 3.
3M. So you see these are all common mistakes you will do. So that means this will become 4 minus 3, it will be 1 mg is equal to 3MA. The cancels, so A is equal to G by 3. And carefully see, it is actually plus. Plus means it is going upwards. So that means the moment you cut the string, what will happen is the spring will be pulling it upwards. Are you able to imagine what will happen? So that means your answer is G comma G by 3. Sorry, it's A and B. So that means G by 3 comma G. So not this one. A is G by 3, and actually they should have given it as minus G because this is going upwards and this is going downwards. Any doubts? So this is after
Sir,
cutting. Yeah.
sir, by using the formula F is equal to m into A, we can directly find the magnitude of acceleration by F divided by m. So the force is G divided by m is 3, so G by 3. Then for the next mass, G divided by 1, that is G. So we can directly find the answer.
Hmm.
A is equal to F divided by N, like this.
If you do it for A, you said 3 mg, and then this side will also be 3 ma. Then you will get a wrong answer. You will get A is equal to G. Do you agree?
Yes, sir.
Right. According to you, what you are saying is sigma F is equal to ma. So F spring. What did you say? I forgot. F. Did you say F spring? But you don't
A
know F
is equal to
spring.
F divided by
F is equal to ma. Okay.
A is equal to F divided by N.
Okay.
The force is gravitational force, so G divided by 3m.
3m. This is 3m you are saying.
Yes, sir, for the first mass.
Okay.
The force is gravitational force acting downwards, so G by 3.
G by
3m acceleration.
what is the value for G, F you will put?
mg gravitational force.
Mg. Yeah.
10 and m cancels.
But here are you not supposed to put 3 mg because the mass is 3 mg? So which means this and this will cancel. So you will get A is equal to G, which is actually wrong. You see, you are not bringing in the spring force at all here. There is a spring force acting. The moment you cut this, the spring is going to pull it upwards, right? So I would say this is not correct. Okay.
Yes, sir. No,
If you still have doubt, you can still try it and you can let me know. You can send it to me. But based on what you said now, I don't think it will work correctly. So my suggestion is, these are all some very very logical problems. So you have to follow this method, right? Without following this method, I don't think you will be able to arrive at the solution correctly. You see, I didn't even take any effort. I just got my answers perfectly correct. You know that this will fall down, this will go upwards. You see, if you follow the method, the answers will come correctly. Okay. So sometimes, shortcut tricks may not work. So, think twice and, use it wisely. Shortcuts, sometimes it's okay, but not all the time it will work. This, I think we have done many questions based on this. So I'm going to leave it to you. Last class we did one problem based on this. So maybe we can do some problems based on friction. I think you asked me a doubt in the WhatsApp sometime back, right? 1 week back. So I think it's something very similar. Starting from rest, a body slides down a 45-degree inclined plane in twice the time it takes to slide down the same distance in the absence of friction. Remember, I think it's the same problem. The coefficient of friction between the body and the inclined plane. So in the first case, you have a block. It's given as Let's take it as theta is equal to 45 degree. So I know that this is going to be mg cos theta. This is going to be mg sin theta. It takes a time of t. The first case there is no friction, it's a smooth surface. So normal reaction will be this way. So if I take this length of the inclined plane as L, so S is equal to ut plus half at square. Since they are given time, I am making use of t here. S is the length of the inclined plane. Initial velocity is 0. Acceleration is downwards this way, g sin theta. There is nothing acting this way. In the next case, there will be a friction acting this way. So mg sin theta will be pulling it downwards. Friction in the table will be acting upwards this way. So that means it will be F friction is equal to mu into N. This is mg cos theta. This is normal reaction N. So F friction is equal to mu into N. So mu into mg cos theta. So do you understand the difference? So here you have only mg sin theta. Here you have friction acting. And they say the time taken is 2t. So that means here acceleration, remember acceleration is force by mass. So that means the m will cancel out. So that means it's only g sin theta. T square. So that is for case 1. Now do it for the case 2. Length is going to be the same, angle is going to be same. Right, so that means L is equal to 0 plus half t square. So half a is this minus this. So listen carefully. I think you had trouble, Vedant, you had trouble in the last time. So mg sin theta minus mu mg cos theta. Is that right? So that is the force which is actually pulling it this way. Following, yes, no?
Yes, sir.
So I can even take the g commonly out here. So mg is taken out. So sin theta minus mu cos theta. So if I remove the mass, it will become acceleration. This is the force which is pulling it downwards. So that means in place of acceleration, I will put g sin theta minus mu cos theta. Time is 2 times t. If you want, I can show that this is a friction surface. So that means friction surface means it's good to show it like this. 2t the whole square. Okay, because it's formula is t square. Here the time is not t, it's 2t because twice the time it takes to slide down the same distance in the absence of friction. So this is absence of friction, this is with friction. That's all. So L is equal to L, so equate this and this, we'll get the answer. I think we are supposed to find the mu. Just for your understanding, I kept it as theta. You can substitute 45 here, right? Sin 45, cos 45. That means 1 by 2 g will go away. So what is left is t square will also go away. So what is left is sin theta is equal to sin theta minus mu cos theta. That's all. Okay, because these terms will go away.
4.
Yeah,
2
you're
square.
right. You're right. 2 squared 4 is there. That means this will be 4 sin theta minus 4 mu cos theta sin theta comes this way, it will become 4 minus 1, it will be 3 sin theta minus 4 will become plus 4 mu cos theta. So mu is equal to 3 by 4 tan theta. Tan 45 is 1, so that means I will get mu is equal to 3 by 4 tan 45. Because sometimes they will change the angle to some other value, so it's better to do it as theta. Let's see if you have 3 by 4. 3 by 4 is nothing but minus 75, so that's minus 0. You see, again and again we are getting the same. I think this was there in the NEET 2025. Is that right, Vedant?
Yes, sir.
That means if you have people who have done the past paper questions, I'm sure they could have answered it. People who are lazy and who didn't do this, obviously they will not be able to do it. If you cannot do it in home, how can you do it in the exam, right? If you see people who are preparing for athletics and swimming and these kind of sports, they will make it much more difficult here, right? Instead of running 100 meters, they will run 5 times, 10 times more distance. Instead of swimming for 50 meters, they will put some kind of a rubber band or something and then swim it. It will make it difficult. So that means here you have to do more and more difficult problems, so that when you go to the actual evaluation process, which is the exam, it will become much more easier. So always remember, you will get what you sow, right? So you cannot say, sir, I will not do past paper questions, but I have to get all the questions right in physics, means obviously not going to happen. Okay. Even people who have done all the past paper questions, all the textbook problems, everything right, and then the NCERT exemplar, you have to do some more, NCERT problems also. If you do all these things, even those people, I would say out of 45 questions, they can get some 30-35 questions right. Okay. So why I'm saying you have to do lot of hard work. Unfortunately, sometimes I feel like students are not understanding the difficulty level of physics. Okay, you have to do a lot of hard work for physics. It's like swimming, initially it's going to be very, very difficult. But once you get the hold of it, once you understand the logic, it will be very, very easy. Only problem is, every problem is different from the other one. You see, now we talked about inclined plane, now they are talking about some chain hanging from the table. So that means each problem will look very different, right? So that's why you have to practice a lot. Okay, go through this. I want some water. A heavy uniform chain lies on a horizontal tabletop if the coefficient of friction between the chain and the table surface is 0.25. and the maximum fraction of the length of the chain that can hang over one edge of the table. So that's a table. Hello, hello, yeah. நான் இப்போ ஒரு கிளாஸில் இருக்கிறேன். நான் திருப்பி உங்களுக்கு கால் பண்ணுறேன். கிளாஸ் முடிச்சுட்டு கால் பண்ணுறேன். So the chain is connected like this, right? So there is some part of the chain which is hanging like this. The question is, as you can imagine, if this weight keeps on increasing, what will happen? This will pull this entire chain downwards, so it will slide down. So they are asking you what is the maximum length portion, right? Maximum percentage you can have it here so that it doesn't fall down. If you go beyond that, right, it will fall down. So that's why they said maximum fraction. Remember, it's not friction, maximum fraction of the length of the chain. The total length, let's say it is L. L dash is the hanging part. That means this part will be L minus L dash. So I can imagine that this part is going to have some weight acting downwards. So M dash G, why M dash G? Only this mass alone will be taken here. Imagine that this edge, right? Imagine that there is like a small thread connected, right? Just like a string. In that string, let's assume that, I'm going to assume that it's an easy way to know, simplify the problem. So I can imagine that tension is acting upwards. That's the same. So in this edge. So that means they said it is hanging over, meaning it is not falling down, which means acceleration is zero in equilibrium. You see, I think we used this concept earlier. As usual, sigma f is equal to ma, most important formula in mechanics. T minus m dash g is equal to m dash a, but a is 0, so I'm going to take this as 0. Total length is having a mass m. That means how much will the small length L dash will have? That is your m dash. So that means for the total length, m dash is nothing but for the total length the mass is capital M. How much it is for small length L dash? Okay, so it's your ratio and proportions. Again and again you will be using these concepts, so please understand. For the total length L, the mass is m. How much it is for L dash? And that is your m dash. So that means m by L into L dash into G. Some people will write it as L dash by L into mg, nothing wrong, right? I find this very logical, so I like to write it like this. Anybody having any trouble? This is for the full chain, this is for the hanging part of the chain. Now coming to the horizontal part. This is the vertical part. The horizontal part, you can imagine that chain is like this. We said there is some friction acting, right? Friction is 0.25. So that means if tension, this tension, here is T, means this tension is, this tension is what is pulling it downwards. If friction is equal to mu into N. Mu into, remember it's not mg, it is only this part of the mass, which means it's going to be m minus m dash. So instead of mg, it will be m minus m dash into g. Why? Because this is m dash and this is m minus m dash. So these are all the places people will make mistakes. Instead of taking m minus m dash, they may directly take it as mg, which will go wrong. M dash is, just now I told you, m by L into L dash into G. So mu mg 1 minus L dash by L. So what else can I do? Friction, tension. So as long as this and this are equal, right? Tension, this and this are equal. I can equate this and this, right? If this becomes bigger, then this will fall down, bigger than this at friction. So that means this and this should be equal. So simplify this, you will get the answer. So if something is not clear, please raise your doubt. This and this should be equal. Only then they will be in equilibrium. So that means mu mg 1 minus L dash by L is equal to mg L dash by L. Mg will cancel. So what is left is mu L minus L dash by L is equal to L dash by L. Actually, I could have kept this separately. So mu minus mu L dash by L, because I am taking this mu inside, is equal to L dash by L. So that means I can take this on this side, so it will become 1 plus mu into L dash by L. So that means L dash by L is equal to 1 plus mu divided by mu. Sorry, mu divided by 1 plus mu. But read the question, they asked you the percentage. So the maximum fraction of the length of the chain that can hang over one edge of the table. So that means fraction percentage means it will be multiplied by 100. Do I have anything close to that? Mu is 0.25. So I think I can substitute the value here. So 0.25 divided by 1 plus 0.25, it will be 1.25. So 25 and 125, it will be 1 by 5. So 1 by 5, if I multiply by 100 for percentage. 1 by 5 and 200, so it will become 20%. So So 20% is your answer. So if you understand the method, if you understand the logics involved, it's a very easy problem. Otherwise, it's a very difficult problem. Okay, I didn't realize the time is already 5 past 9, so I'm going to stop here. I have been going very slowly, right? So it is your duty to take care and study then and there properly. Any doubts? Bhumika following
No, sir, it
everything?
is clear.
Bhumika following everything? No answer. Revati? Vedant, you're okay. Okay. What about Revati? Are you able to follow everything?
Yes, sir.
Okay. Are you doing the homeworks and everything properly? Okay. Thank you all. Bye.